afternoon, everyone. Welcome back. It's always hard to be the session right after lunch. How was food? Was it good? Right, Google is known for good food, so. But did you eat too much so that now you're a little sleepy? I hope not. Well, actually, I'm not worried, because what we're going to talk about is going to be really exciting and close and dear to your heart, DevOps. So we're going to be able to have you engaged for the next hour. We're going to talk about how to not only write code, but also ship it to production, maintain your live site, and troubleshoot and debug successfully. I'm Ray Wang. I'm a product manager on the Google Cloud Developer Experience team. And I have here with me Chris Smith, who is a tech lead on the team and my demo buddy today. Okay, slides. Okay, I used to work on the back end of a large-scale service. It was really exciting, the kind of problems you get only when the scale is large, and the number of customers you get to impact. But it was also frustrating. We had a lot of really good ideas. We wanted to launch a new app and add features and impact customers. But in the end, the time that we got to spend on writing code was about less than half the time. So what were we doing, right? We were coordinating releases, build and test, and trying to deploy to production, debug, the live site duties. Not to mention when I was on call, I was paged around the clock. That wasn't fun. I didn't have a life. Here at Google, we believe that a cloud is not just about giving you raw VM and storage resources. You deserve to have a platform that can take care of all the time-consuming, repetitive DevOps tasks so that you can be freed up to work on what's more important, to launch that new app, to build that new business idea, and still have a life, right? And we want to share this dream with you. We want to invite you to join us as we begin this journey to set a higher bar for what cloud can do for you. In the next hour, you're going to be able to show some of the first, you're going to be able to see some of the first steps that we have made, as well as the directions that we're heading. And now first, I have a treat for you. So some of you might know that Google runs some pretty large apps like Google.com, Gmail, YouTube. Do they ring any bell? You use them, right? Our developers work efficiently to build and run these applications because they have access to a great stack of tools that Google spent the last 15 years building and perfecting. And now today, we have the privilege of hearing from the person at the heart of this, Melody McFessel, our engineering director for developer infrastructure.
Thanks a lot, Ray. So hi, I'm Melody. I lead a team at Google focused on developer tooling and infrastructure. So what we do is we organize software development at Google and hopefully make it fun, but most importantly, make it fast and scalable. And it's all about Google engineers. So from the time that engineers sit down to write code, to search it, to version it, and then to build, test, and release it reliably to our cloud, developer tooling enables engineers to do all of those things. So our whole mission is to make engineers' lives easier, so engineers can focus on code. And as you heard Urs say in the keynote, right, we want you to focus on what you love, right, writing code. So, but it's not just about Google engineers. It's about all of you. We want to take what we've built internally and offer it to you. So I'm going to talk a little bit now about some of our internal tools to set the stage for the things that we want to offer you. OK, so how does Google build? Well, our build system supports a variety of languages. And we have a recipe, right, for how to build our software. We enable engineers to express relationships between libraries and binaries and to get fast feedback on their build. Well, you might be asking, how does this really happen? Well, under the hood, just think massive parallelism. Build actions being farmed out to thousands of dedicated worker machines, right? Getting the full power of Google's cloud. But also, we cache results across machines and users so that there's a transparent speed up for everyone when somebody builds. So let me tell you a story. So before I joined Google, it was not uncommon for me to say, kick off a build before I left the office. I'd go home, and I'd get a good night's sleep, and I'd come back, and then I'd see what happened, right? Like, Were there breakages? I'd have to go figure that out, and then I'd have to start it all over again. So when I joined Google, I thought, wow, this is amazing, right? This is not where I came from in terms of velocity and speed and feedback for me as an engineer. And I've seen over the years the speed and the scale increase at Google. So now, talk to Nooglers, so new Google engineers. And they come in and they say the same thing to me. Melody, wow, these developer tools are amazing. But wait, 1 month later, it's too slow. It's too slow to get a build result in under a minute or in a matter of seconds, right? It's not enough. So the point I want to make there is that the speed and the scale are something that we do well, and we're continuing to set the bar higher and higher for ourselves. Okay, what does Google do for testing, right? Because testing and developing safely go hand in hand, right? So we test the entire code base after every repo update, right? And the other thing is that we provide testing before submit, right? Before submit, so that we can identify breakages before they even happen. And I think that's pretty cool. Before submit, you know it's going to be broken, right? The other thing that we do is we know that we need to test in a variety of environments. So whether it's development or staging or testing, we make it easy for engineers to be able to switch environments and do the testing that they need to do. We also need to think about things like automated web app testing, right? All the various OS and browser combinations that our users use, we need to be able to test all of those. And so we run millions of tests a day and 20 plus OS and browser combinations to make sure what's going out the door is the best quality. Okay, so let's talk a little bit about what Google does internally to manage our code. So we have a single code tree, right, with very fast access. So I know many of you, DVCS, raise your hands. There's audience participation. I should have warned you. I'm going to be asking you lots of questions. Okay, just one? Really? Okay. All right. So even though we have this single tree, we do want to provide a lot of flexibility around workflows for engineers, so we support some Git-like workflows internally. We merge early and often, right? We're constantly doing integrations with the code. The other thing that I think is pretty amazing is that the code base is very open, right? Engineers can go look, view, modify, experiment with code across the entire repo. So I think that's pretty amazing, right? That level of openness. We also, as engineers, I think I can safely say, we love languages, right? We love languages. So we support a variety of languages. C++, Go, Java, Python, right? It's important. We need to pick the appropriate language for the problem that we're trying to solve. Okay, well, what does this actually mean for an engineer? So having a single code tree means that we can do things like globally analyze and refactor our code. And with over 300 million plus lines of code at Google, keeping the code tree clean is very important to us. So here's another story, right? I've seen this multiple times in our history of changing an API, right? What do we need to do? We need to find all the usage of that API. We generate CLs to send to the code owners, right? Those need to go through review and testing and push out. These large-scale code changes and massive refactorings have enabled us to increase our velocity. And we get that benefit with a single code tree. Fast access means that engineers can answer all kinds of interesting questions about the code. Who's using my API? What's this library? Look for another piece of code. And merging early and often enables us to do easy rollback when things go wrong, right? And we know we're going to break things. So we need to make sure we can roll back safely. Having the code be open means that we can help each other out. We can help fix bugs, right? An issue comes up, we can bring together the right people to get it fixed. And quality is very important to us. So we do have mandatory code review by experts and our code developers. So I'm going to take a pause there for a second and ask you, how many builds do you think Google does in a day? Audience participation. How many? Millions. Okay, how many tests? One build. That's a good one. How many tests? Anyone? Bueller?
As many as builds.
Okay. All right, well, here's some of the stats that we're talking about. So around 800,000 builds a day, leading to 2 petabytes of build output. 25,000 change lists in a day, with per minute ranging from 20 plus per minute to 60 plus per minute at peak. So the tooling that we've built at Google, really, the whole focus is to enable velocity, and speed and scale are critical for us. So working at speed and scale, it's a challenge. And the engineers we keep raising the bar for ourselves, right? But what's it like? What's the culture like? And I just wanted to point out a couple of things, right? This idea of having the code base be open, collaboration and code development are key, right? With this accountability to help each other fix issues. Sharing code across products means that engineers don't have to write code that already exists, right? We have common libraries and common services and different pieces that we can reuse, and that leads to velocity. And engineers have autonomy, right? Engineers can make their own choices around what makes them productive. So how many Emacs users? Audience participation? Okay. All right, how about Eclipse? All right. Okay, how about, dare I say, VI? Yeah, there we go. Okay. Right, so we know that we need to offer a variety of tools and options so that engineers have this choice to pick what works for them. And near and dear to my heart, as an engineering team building tools and infrastructure for other engineers, we need to make sure it makes us productive, right? We use it ourselves. We do this thing called dog fooding, right, where we make sure that it works before sending it out to our users. So I don't know if you can tell. I'm a little proud of what we've built internally. I'm a little proud of it. And it sounds pretty good, right? Pretty good. Okay. Well, we struggle. And not to air any dirty laundry here, but I will. It's never fast enough. Every single engineer that I talk to, it's not fast enough, right? The build is too slow. Engineers want and expect almost instantaneous results for what's broken, right? What test is broken, so that you can fix it, right? So we can get features out to our users. The rate of change is so fast, right? It's hard to keep up sometimes. So if you have dependencies in storage, right, or in certain other areas of the stack, it's frustrating when things break, right? It can slow us down. And that's something that we're working on. Quality processes, very important to us. They help us a lot. Sometimes they slow us down. It takes too long to turn things around, right? And we want to keep this focus on automation and velocity for engineers. And finally, I just want to highlight that finding and fixing bugs, it's tough for us too, right? I need to go look at this log file and this log file, and I got an alert. I'm not sure that's related, and I need to figure out what needs to be monitored. So there's a session right after this to talk about the insight we want to give you into your service. But I just want to acknowledge that this is something that we struggle with, and we want to make it better for everyone. So we think you deserve better, right? As you heard Ur say today, right, we're not keeping any of these tools to ourselves. So whether you're Gmail or Snapchat, we're going to focus on making the best platform that everyone can build on. And I'm really excited about the opportunity to take the experience, knowledge, and tools that we have internally and offer these to you. We want to develop a community, right, for third parties. It's easy for third parties and developers to plug in functionality, to innovate in new markets and tools, and to raise the overall value of the ecosystem, right, to make it better for all of us. So with that, I'm going to turn it over to Ray and Chris to talk about the specifics of what we're going to launch: productive developer tooling, continuous delivery system, and better DevOps. Thanks so much for being here today.
So as we just heard from Melody, that DevOps is hard for everyone. It's hard at Google too. regardless of whether it's making 100,000 builds at Google or it's your own company making 3 builds a day, it's hard, it's time-consuming. Developers all need support from a great platform to be productive and innovative. So that's why we have started now building these DevOps tools, not only for Google developers, but more importantly for you, the Google Cloud customers. Let's dive into them. First, I want to talk about code. The soul of application lies in the code you write. So you need a great experience working on your code on the cloud. We did a lot of user research study. That's when we go out and talk to many developers and actually sit there for hours and watch how you work. And we learned there are a few things that your favorite IDEs don't do for you yet. First of all, how many of you only work from a single desktop all the time? One? OK. No laptops, no phone, no tablets. So these days, a lot of applications need to be up 24/7. But we can't be chained to our desk for that long, right? You have a life, you're on the go. Luckily, you have devices. And your code needs to be accessible from where you are. The other thing we observed was that many of you need to switch between multiple windows to get your work done. Because it's not just your code. You also want to look at logs and traces and metrics and analytics. The big dual monitor with 8 screens that gets your eyes busy all the time, that probably looks cool, and it's probably how Hollywood wants to think about it. But you know and I know that's not good for your productivity. The context switching slows you down. So the ideal cloud should offer you easy access to that entire stack of data, put in the context that you want. We don't like it when things go wrong. We really don't like it, but it's life and it happens. Today, when stuff goes wrong, it's often really difficult to find the culprit code. Because just think about how you do that. First, you have to figure out which releases have been deployed to which environment, at what time, by who, right? And then you have to chase down which code commits went into these releases. We think a powerful diffing tool should easily help you answer the question of what has changed without requiring you to manually look into these different sources of data. So now let's see the real thing. Chris is going to show us some demos of the features we built to solve these problems.
Hello, I'm Chris Smith. I'm a tech lead on the team here, and I'm very excited about developer tools and tooling and being more productive. But I'm going to let you in on a secret today, and that's my first love is game development, which is why I am super stoked today to launch my brand new, super exciting, original IP, Fluttery Bird. Now, of course, right? Yeah! Now, this may look like a cheap knockoff of Flappy Bird, and it may seem like a cheap knockoff of Flappy Bird, but I assure you it's super awesome and a lot of fun. In honesty, I can't take credit for it. This is a clone of Clumsy Bird, which is also a clone of Flappy Bird. It's clones all the way down. But what I have done is added a backend using Google App Engine to keep track of a worldwide leaderboard. I just scored 2 points, and now if I go to this high scores page, I can see those 2 points. Now, I see a few of you maybe in the audience trying to play along, and I don't see these other scores even if I refresh because there's a bug here. You see, earlier today I got a text message from a friend like, hey, my scores aren't showing up, what's the deal? And we can verify this very quick by just going to in an incognito window, playing real quick, scoring a point, and then verifying that, alas, the score isn't being uploaded. So there's a problem here with my production app and on the launch day of Fluttery Bird. So what am I going to do? I'm going to fix this by using all the DevOps tools that we've built inside of the Google Developers Console. So I'm going to quickly load it up, jump to my project, and the first thing I'd like to show you is the release history page. Open up Cloud Development and Release History, and this is showing me all the deployments of my application, Flappy Bird. Something I'd like to bring your attention to is the changes column. So here's a deployment where I fixed the high score sorting. If I open up the diffs page, it will show me all the commits that were included with this deployment. That is all the changes that were made, and as well as showing me the diffs inline so I can quickly scan what's happened to my application. So using this feature, if I go back, I could probably get a sense on what the problem was from this dubious refactor user service change. But I don't want to give away all my secrets. So another way to debug or troubleshoot this app is to just go straight to the logs. Loading up the new App Engine Logs viewer, I can filter this by error and scroll the way down, and sure enough, I see some errors uploading high scores. Error uploading high score, non-admin user attempting to upload a high score. Well, that doesn't sound right. I mean, sure, as an admin, I can upload high scores, but I imagine that other people would want to use this high score leaderboard as well. Okay, so what I'm about to show you may be the greatest developer feature ever in the history of mankind. Quick question, right? Quick question. Why is this that weird shade of blue? In fact, if I hover my mouse over highscoreservice.java, that gets underlined for some reason. It's exactly what you think it is. It's a link, a hyperlink, boom, from the runtime error logs directly to your source code. Not only just some random file, but the specific commit and the specific line where that error occurred. So going straight from the App Engine logs, I can jump right to the problem, where it occurred in my code, and sure enough, some bonehead developer on the team, this guy, introduced a problem. So what I'm going to do now is, I guess, drive to the office, go to my desktop, make the change, commit it, et cetera, or right here on stage from my web browser, or maybe my tablet, or possibly even a phone, I can just click Edit. I'm going to make this change, just comment out this piece of code, and then I'm going to commit it all from my browser. All right, and this is going to commit, but not only that, it's then going to build my application, run its unit tests, and once everything's green, deploy Flutterybird worldwide, fixing the problem and saving the day. I'll talk more about our release and deployment tools in a minute, but for now, I'd like to give it back to Ray.
Now that Mike's on, I just want to say again, go Flutterybird. So now let's look at a recap of the features that you just saw in the demo. And by the way, all the features you just saw will be coming to you in the next few weeks. To help you to easily work with your code in the cloud, we're offering you Google-hosted Git repos. And you also saw the browser-based file viewer and code editor. And not only that, the ability to check in your code right from there, where your code is. To help bring together your code and the runtime data, we're offering you log-to-source linking. That's when you can go directly from the message in your log file into the code that caused the error. And that's just a first step. We know that logs are not the only thing you look at. They're also monitoring metrics, other analytics data. And we're thinking about bringing all of them here so that your code can become the canvas on which you can display and analyze your application's performance data. To help you answer the question of what has changed, we're giving you not only code diff, that's normal, everybody does that, but more importantly, deployment diff. So you can easily tell the delta that has happened between two deployments. So now you have your code. What do you do when you have your code after code is done? You don't just keep it sitting around in your repo, right? You want to deploy it. That's when it becomes real. So let's talk about deployments. Deployment is the lifeblood to your application. Deployment time is just about the most exciting time because that's when all your hard work pays off, right? That's when your app hits the market, customers start using it, that's when you become the hero. But it's also a very scary time. That just tends to be when things go wrong. How many of you have had outages right when you deploy the new version of an app? Happens, right? You're with me there. So you definitely want your deployments to be reliable. That's the most important thing. You want to have the confidence that whatever you're deploying to your production does not have a critical bug in it. And you certainly don't want to be the one paged at 2 o'clock in the morning because you just brought down the app. You want your deployments to be fast. You don't want to wait for hours or days for your work to hit live site to be used by customers. You want that to happen in a matter of minutes. The other thing that fast deployments do for you is if you can deploy and release fast, then you can end up doing many frequent, smaller releases. Now, why is that good for you? Let's just imagine if you're sending a release that contains 100 code changes into production, something goes wrong. What do? Right, you have to roll back that entire package, and then take it apart, out of the 100 changes, find the one that's the issue, cherry pick it out, put the 99 back together, send it to production, and hope that you got the right one. But if you can do fast and more frequent and smaller releases, if your release only contains 1 or 2 code changes, things go wrong, roll back and you're done, right? And we don't like slow deployments, we want them to be fast. But there's one thing that can be even worse than slow deployments. That's not knowing where your changes are. Have you had that happen to you? We all know what that's like, right? Your changes need to be visible and predictable. When I used to run deployment for a pretty big backend, I found half of my job became answering exactly 3 questions. Where are my changes? When are they going to get to production? And what has been deployed to this environment? So after a while, I learned to make myself more productive. I set up an auto-response message with some of the answers in that made the line outside of my office a little shorter. It shouldn't be that hard. You shouldn't need a crystal ball just to tell when your changes will get to production. And we certainly don't want you to keep pestering your release managers. And last but not least, we know there are great best practices that have been proven, and you can use tools to adapt them. But at the end of the day, every person and every team is different. You might want to build and test differently than all the other developers. And you want to decide what environments you want to use. You might have specific approval policies that you need to put into place. And we want to support you there. We want to meet you where you are. Now it's exciting demo time again.
All right. So we use this push-to-deploy feature to roll out the fix to Flutterybird, therefore saving the day. I see somebody who's tried to play it on their laptop, and evidently that hasn't fixed or fixed the issue, and we'll see what the deal is. But first, let me explain a little bit of how this is all happening. You see, last summer we initially launched push-to-deploy. That is a Git source code repo that whenever you make a commit to, it automatically deploys it to App Engine. This is an alternative to using the App Engine SDK and deploying manually. And it's a way to be more productive if you're using Python or PHP, languages that don't require a build. But if you want to use Java, or if you want to run some unit tests before you deploy your application, well, then you would be out of luck. So that's why this quarter we've launched push-to-deploy plus build. If I go to the Releases tab and under Configuration, you'll be able to see the different kinds of releases. Not only is there vanilla push-to-deploy or push-to-deploy classic, but also offering a build machine for Java Maven-based builds, Java using the Gradle build system, or Python with nose tests, PHP with PHP unit tests. And I want to spend a couple of minutes explaining part of the technology on how this works. So whenever you make a commit to a push-to-deploy enabled repo, if it requires a build or test, we'll provision a Google Compute Engine virtual machine for your source code to do the build and the test. Normally this happens on demand, but I've modified this project so that it's still running so I can show it to you. If in the developer console I quickly refresh this page, and it will show a Compute Engine VM that is running the actual build machine. In fact, if you look over the past day, each spike in CPU utilization is when I've triggered a build. And so this is the actual machine, and you may be wondering, so what's actually doing the build? Is it a shell script? Is it some Google specialized build farm or whatnot? Well, let's find out. If I open up that port 8080 on that machine, it's going to show me the man behind the curtain, which is Jenkins, an open source continuous integration service. Quick show of hands, how many people here have heard of Jenkins, used Jenkins? Oh, wow. Okay, so many of you. Hopefully you're not familiar with, or you're familiar with Jenkins. Well, this is the job that we've created on this machine, aptly titled, My Job. I can go to the configuration of this job, and I'm just going to quickly scan over all the various things that we've set up. First, we do the build. upload the results, run the tests, push to App Engine, the standard sort of fare that you would expect. Now there's a key point I'd like to highlight here, which is that we're using the Google Cloud Platform to build tools for the Google Cloud Platform. Not only using Compute Engine for the build machine, but we're also taking advantage of Google Cloud Storage. If I go over to the Cloud Storage tab, you can see that we create a push-to-deploy bucket. This bucket stores the results, build results, test results, and metadata for each deployment that it does. So these folder names, these are the Git caches that are being used. And if I open up one of these, you can see the raw build log that is the output from Jenkins, the test results, as well as the actual payload that we've deployed. In fact, we use the metadata for this object to power information on the release history page. So I'm going to go to that real quick so I can show you how flawlessly the system has worked. We issued the commit through the web browser, did the build, ran the test, deployed it, made Flutterybird a worldwide success, or it has failed because the tests have failed. I'm gonna pretend like I'm surprised, but I've been working on this demo for weeks, so don't worry. I can drill into the test, see these are the operations that the build machine has performed, but of course the tests have failed. So still within the Google Developer Console, I can drill into that and see, well, what actually occurred. So it turns out some of the tests passed, but the high score service did not throw an exception. Just love it when you have these sorts of bugs. You have some bad logic in your program, so you remove it, and then you introduce a new bug, which is the unit test that expected that bad logic now failed. You can't win them all. Well, next I'm going to show you using the GCloud SDK and going to the command line and just fixing this using my existing Git and tools and my existing workflow. But before I do that, I want to show you one more thing, which is going back to the Google repo. It's great that Google has a Git source code repo that will enable you to do this push to deploy and build experience. But how many people here aren't already using Google for their Git hosting, or maybe using Bitbucket or GitHub? How many people here use GitHub? All right, similar to Jenkins, most of you, which is great. Well, we've launched a feature called connected repos. That is a way to mirror an existing GitHub repo and have that transparently and seamlessly work with the tooling that we've provided. So you can use your Git repo just like you do today, but whenever you do a push, without needing to configure the remotes manually, it will just automatically trigger these sorts of workflows. So to give you an example, I have a connected repo, the App Engine Python Hello World, and I'm going to use the GitHub-based editor to just change it. It prints Hello World and the word orange. Why don't we change that to Apple? Oh, I guess first, this is the current state of the application. Swift Catfish 511. You can see it prints orange, which is so you know. But I'm going to change that to Apple, scroll down, and all right. And then I'm going to make this commit directly in GitHub. But you could imagine this is you pushing to your Git repository like you also do. Shortly, this is going to trigger the push to deploy experience that we've expected, and then we'll hit refresh on Swift Catfish 511, and it will print the word Apple. But first, let me hand it back to Ray.
Thank you, Chris. And can we go back to the slides, please? I want to show you again the flow of the demo that you just saw. You can make a code commit from into either the Google hosted Git repo or your own GitHub repo, so nothing needs to change. Just use the same commands that you used today. The commit triggers push to deploy, which then in turn invokes Jenkins to run through the build, test, and deploy steps for your application. The status results are displayed through UI and CLI, and we also preserve high-fidelity logs and put them into your Google Cloud Storage bucket. So these are the features that you just saw. We know that to help your releases and deployments to be fast and reliable, automation is the best way. there are some things that machines just do better than us, right? Such as repetitive release tasks, so let's dedicate to them. For that, we have launched Push to Deploy to automate the build, test, deploy steps for you. But we also know that many of you need to use a number of different environments before your code hits production to validate that it's working correctly. Having to push to individual environment is a hassle, so we are now working on expanding this to a full multi-stage pipeline with permission and quality gates between them. To give you visibility into your deployments, our UI and CLI tools offer you notifications, statuses, standard outs, a history of all your past builds and deployments, but more importantly, linking them back into your code commits. To meet you where you are and help you to customize how to do your releases, we have built Push to Deploy on top of Jenkins that I saw many of you already use and already familiar with. I just want to emphasize that we take the hard work of hosting Jenkins, so you don't have to worry about setting up, monitoring, maintenance, all that annoying stuff. It's on us. So you can focus on the more important stuff, which is your application. In the current version of Push to Deploy, you can select which language your application wants to use, which in turn selects the number of tasks to run through for Push to Deploy. And going forward, we want to make this a more open platform, so you can specify your configurations, customize your build and test parameters, and even bring your own Jenkins plugin. So that was deployment, and that was code. We saw lots of great features in the UI, in the Google console. But I do know for some of you that command line is what you want to use on a daily basis. So who are here with me, command line users? Yeah, a lot of you, right? So you're going to love it. Next, let's talk about the Google Cloud SDK and command line tools. So when we think about command line, we think of fast and light ways to do things. And therefore, everything around the command line tool should be fast and easy. And that means it's easy to set up, it's easy to maintain for any environment you work in and for any member of your development team. It should also be easy to learn, to ramp up, to use, especially if you already use our UI or API, learning command line should be straightforward. And if command line is how you want to do things, it should not only work for 1 or 2 commands. It really should be available for all the things you want to do on Google Cloud. So now we're going to go back to demos, and Chris is going to fix his unit test.
So just to keep me honest about the GitHub connected repos, I'm going to refresh Swift Catfish. Just like we expected, the Git push was all the way through our system and deployed. All right, so let's go back to Fluttery Bird, the world's greatest app, I might add. So we have a problem. The build works, but we need to fix this unit test. So again, what's the quickest way to do that? Well, I showed you the web-based editor. Now I'll show you the GCloud SDK. So I can do this on the command line. So you've probably seen this before, but how do you install the GCloud SDK? Here's a quick cheat sheet. Curl, crazy long URL, pipe to bash. That's all you need. All right, I've already installed the GCloud SDK on this machine, so if I wanted to know how to use it, I could just type help, okay? And that will list all the things that I can do and sprockets. But I'd like to remind you all of something. It is the year 2014. We live in the future, and although we don't have flying cars yet, I think we can expect a few other nice features from our tools. So I'm just going to type GCloud and press tab twice, and now we finally have auto-completion right in our console. So if I want to know what I can do with the components that I have installed from the GCloud SDK, GCloud comp, tab will autocomplete the components, and those are the operations. And then finally, GCloud. And I can list all the things that I have installed. Okay. So great. Well, one problem that you'll always run into when you're using command line tools, such as the current generation of the previous generation of the App Engine SDK, is how do you authenticate yourself? Well, you could break your flow and just have to type in your password every few minutes. Or you could set up an application-specific password, but there's some security concerns there. Or you could use OAuth, and that's great, but then you have to authorize it for every single different resource, for using GCutil, for pushing to App Engine, maybe cloud storage as well. Well, I'm happy to talk about how the GCloud SDK has solved that with one command. If I want to authenticate and log in with all my command line tools as me, all I need to type is GCloud auth login. This is going to take me through a single OAuth flow so I can authorize the GCloud SDK to perform all the cloud operations for the Google Cloud Platform on the behalf of moi. So I click accept, and I'm good to go. But not only that, I can type GCloud auth list and show all the different accounts that I have activated on with the SDK. So if you use two different Google accounts, say one for managing your prod environments or one for managing your dev and test environments, you can seamlessly switch between the two, all with a couple of commands. Okay, so enough about GCloud. Let's get back to fixing Fluttery-Bird. Google has the Git repo in the cloud. How do I bring that to my local machine? I could go back to the web, find the right URL, git clone, set it all up myself, or I can just type GCloud init Fluttery-Bird, where Fluttery-Bird is the project name. This is going to automatically bring all the context and set up my Git repository, and so it's ready to go for me to make local changes. I'm going to change directories. So here's all the source code that I have. In fact, if I type git log, you can even see the commit that I made on stage a few minutes ago. And so from here, I can just use the tools that I'm used to. For example, the world's greatest operating system, I mean text editor, Emacs. And I can finally just get rid of that unit test. All right. And then I can use the standard Git workflow that I'm used to. And so to fix Fluttery-Bird once and for all, trigger the cloud build, cloud test, and deployment, I end it all with a git push. So while I'm super excited about the developer tools that we're building and showing today, as well as the ways in which it can make you more productive, the thing that excites me the most is that we're just getting started. And with that, I'll give it to Ray.
To bring it home, here are the features that you just saw. To give you an easy getting started experience, the SDK can be installed by a single command line. The component manager lets you see which components have been installed and add new ones as needed. You no longer have to worry about, do I have the latest version of SDK or not, because we have auto-updated notifications that will keep things up to date for you. I love GCloud, but I have to tell my favorite command there is GCloud init. You saw how easily it provisioned the entire workspace for any project you want to work on in just a matter of seconds. We want to make command line tool easy for you to use. We don't want you to have to memorize and spelling the other commands. So we provide you with auto-completion. You can just tab, and it's there. There's unified help in a tool that allows you to easily discover and learn new commands as you go. And we also make a big effort to try to keep command line, UI, and API consistent, so you only have to learn it once. In a single SDK, you get all the tools for Google Cloud. Some of you, I saw show of hands, can see a show of hands, might have used GCutil or app config in the past, right? Remember, you had to download them all separately, keep them up to date, install them, learn them separately. Well, that was the past. Now they are coming to GCloud, so there's only one tool you need to care about. Now, in the last 45 minutes, you saw all the dev tools that we have built this far for Google Cloud Platform. You remember the browser-based code editor diffing tool to log to source linking, push to deploy, and an all-in-one Cloud SDK. These are just our first steps. We're going to continue to be relentless in our quest to give you the DevOps experience that you deserve. Thank you, and with that, we're happy to take any questions. So you also have my email there. If you want to reach out and ask questions offline, you can send your email.
How about the GitHub integration? It was announced this morning, but I don't think it's available yet. So using GitHub instead of the Google repo?
It's there. We'll be launching it, I think, publicly in a couple of weeks, or like rolling it out wider in a couple of weeks.
Okay.
So most of the demos that you just saw, if they're not already in production, they're currently in our Canary environment. They're like hot off the press. They're on their way, rolling out in the next few weeks.
You may have saw a link on Brad Abrams' talk about the Trusted Tester program at Google. That's how you can get a sneak peek at some of the features that we're working on.
In the Git repository, is there a way to sandbox, if you invite a developer to sandbox the access to the certain portions of the project, or do they automatically just get access to the entire project?
Git currently doesn't, our Git setup currently does not support that. The ACLs for the repo, as in who can access it, are tied to the project. So people who have edit access to that project can modify any part of the Git source repo.
And there's a question here.
Or there's the, let's follow the line.
Hey, I'm just really curious. You talked earlier that you have one source tree, but the tooling that you're generating now seems to deal with if you have, say, one repo, it goes to one instance. So it seems like kind of different concepts. And I've always done it the more repo way, but are you working on, if you have a giant source tree, push out of this branch of it, or how do you relate those concepts?
So that's a really good question. It's talking about, within Google, we have a single repo, as Melody talked about, but we understand that's, people do these things differently. There's some companies that like to have just a single repo. There's some companies that like to have, we've had customers with a few hundred repos on GitHub. And that's where we think flexibility is really important. We want to be able to support these different modes of working. And we also want to make sure that the benefits on both sides, we can give it to these both camps. For example, one benefit of having one repo is that it's easy to search across them, and it's also easy to reference different parts of things. And when a common library, when there's an issue in a common library, it's fixed for everybody. But we think these benefits can be true even if your preferred way of working is having multiple repos, and that's something we're working on.
So do you guys currently offer any way to speed up the tests themselves? Do you guys do any kind of parallelism in what you guys are offering, or is it basically just like hosted Jenkins?
Currently, we don't have any tooling about speeding up tests. It's just, as quickly as you can configure the Jenkins master to execute them. But that is a problem that's on our radar. All right, I think we have time for one or two more questions.
And I also want to add that sometimes it means allowing you to be, for example, be able to choose which size of VM to host your Jenkins, depends on how much your workload, and that's definitely something we're looking at. Yes, one more there. So the question is, do all the command line tools run Windows as well? And we actually have an expert here who can answer that question. Manfred, you want to comment? Yes.
Yes.
The answer is simple, yes.
All right.
Okay.
Great.
All right, thank you.
Thank you.